Thank you, everyone. Welcome here. So today we are going to see if the remote works. Demo effect. It's okay. I will click on it. So we're going to see how the integration of API platform went through in PrestaShop. Was it easy, a walk in the park, or was it a struggle? We hoped it would be super easy, but there were a bit of obstacles in the way. So a little bit about me. So I'm Jonathan Lelièvre. I'm a lead developer at PrestaShop for the open source project. I've been doing it for 3 years now, and I've been a maintainer on the project since 2018. And I have 2 years of experience with API platform, which means this was my first experience ever with API platform. And as such was the rest of the team, but we learned a lot. So let's start. A little bit of context about what we needed and why we integrated API platform. We used to have an old API for our admin, but it's really old. It's like more than 10 years old. It's been on it's an implementation based on the object model, which is our persistent layer, but it's the legacy one that we plan on removing someday. It performed basic CRUD operation with no intelligence. It's really old compared to new web standard, and sadly it has no test because it's almost untestable, at least effectively. It's hard to maintain and it's scary to modify because of all this. So what we wanted to do was create a new admin API for PrestaShop, not one that would be used for the front. This will come in a few years, but for now we want to focus on the back office part. We wanted to bring a more secure API that allows us tracking action to know which person or which client actually did the action it did through the API. Give it more intelligence than the basic CRUD that we had so far. Be more in tune with the modern standard. And most of all, it needs to be extendable by the modules. PrestaShop is a core solution, but it comes with a lot of modules that can integrate inside it. And it was critical for us that this new feature and this new admin API would be extendable through the modules as well. So the chosen solution were to rely on OAuth authentication to have better security. We use a PHP Leak library to handle this. We chose API platform framework for the API part, or the resource server. We started with the 2.7 version back when we started this as a POC in the 8.2 version. And recently we released the 9.0 with a minimum version for PHP that was 8.1. So it allowed us to upgrade to the 3.4. And I believe we can use the 4 version because it's minimum 8.2, so it's not in sync with our requirements. We wanted it to be based on CQRS commands and queries. This is the base architecture that we use for all the migration that we've been doing these recent years. And as I said before, we want it to be module first in mind. The reason we wanted it to be module first is because we know we need our community to help us with this new API. We are only 4 developers in the team currently, and we need to handle 97 object models. Just to give you a bit of number, we estimate that we'll have more than 500 endpoints. So if we do it just with us, it would take too much time. So the idea was that we can rely on the contributors to help us build this so that they also feel involved in this new feature. And to do that, because many of our contributors don't know yet about OAuth, REST APIs convention, or even API platform. So we wanted to make it as simple as possible for them to contribute. So just a bit of context about what we added, aside from the API platform integration. We added the OAuth authentication. So for the context, in our use case, the PrestaShop website well, the merchant is the resource owner. The client could be an OMS or a PIM or any external tool that needs to interact with your PrestaShop website. The resource owner itself, which responds the API resources, is also the PrestaShop website. And the authorization server is also the PrestaShop website. But not only. I will tell you more about this soon. Since for now, all our use cases are communication between server to server, we only implemented client credentials workflow. It doesn't mean we won't add other workflow later, but we wanted to focus on this use case, which was the most important for us based on our users. So just a quick view of the workflow that I'm sure you all know. You get an API exhaust token request to your authorization server. It will respond you with a JWT token that you can then use when you request any API on the resource server. That will check that your token is valid, check that the scope that are defined inside it are in tune with the required scope for the resource, and if everything is okay, you get your response. In our cases, PrestaShop acts both as the authorization server and the resource server, because we wanted the solution to be standalone. We have many users who don't have big stacks, and it needs to work just out of the box with PrestaShop. But as I said, we don't want only to be limited by only what PrestaShop can do. If you need another external authentication server, you can create a module, and it will only need to implement this interface. So it's only two functions. The first is here to see if the token is valid, and when it's valid, you return a DTO that represents your user. So the same example that I showed you earlier, this time you get your token from the authorization server, which would be Keycloak. And when you request to the server your resource, we will get the public key, check if it's valid. It was just a simple POC. And if the JWT token is considered okay, then we return the response. But we could imagine a more advanced use case where your module actually calls the authorization server back and forth every time you perform a request, just to make sure you have the correct authorization and to check if your token hasn't been invalidated. Sorry. Just a quick sip. So back to what actually interests us today, the API platform integration. So why did we choose API platform? Mostly because it's already known by many developers. It has a strong community, so it can help us building it, and it will help our users and developers to also use it. It has a clear implementation of the provider and processor, which give us an abstraction which was really easy to comprehend to build our custom behavior. It also provides doctrine entities rapid development, which we think would be a good plus for the community. We do need custom behavior for all our core APIs, but that doesn't mean the module do. So if they can build some APIs faster, then it's a good thing for them. And one critical thing is that it integrated OpenAPI doc generation. So that means that out of the box, we already have all the API that is documented for our DevDoc. So as I said, we wanted the API to be based on CQRS because that's the architecture we chose over the years. And it gives a more business logic and domain approach to the API, which will be better than the old CRUD approach. And we can capitalize on all the CQRS code that we already have implemented that represent around 80% today of our feature. So it means 80% of the PrestaShop feature will be available through those CQRS code. It also guarantees that we'll have the same behavior in the form as in the API, since the form in your back office is based on the CQRS code, and it will be the same code that will be executed through the API. And it's supported by BHAT test, so it means we trust this code, we know that it works, and if it doesn't, we know that we can improve it with more tests to avoid any regression in the future. So how did we build this? Basically, we needed some bridges. We needed roughly 3 main components for this. So one query provider, which implements the provider interface, and it's only for read operation. We have one command processor that is responsible for write operation, and that executes our CQRS command. But it can also optionally execute a CQRS query afterwards, because we wanted to implement some REST API. Like when you post a new entity, we want to fetch the whole entity as a result in the response, and the same for update. Even if you do a patch or a partial update, we want the full entity to be returned. So the command processor is able to execute the command and the query and return the full result. And lastly, for pagination, we already have a component inside our pages, which is the grid component. So I won't get into the detail. It's not pure CQRS, but it's already implemented on all our pages. So we wanted to capitalize on this as well. So we created a dedicated provider that is able to execute all the grid data factory that are already implemented. So that's for the execution part, and the rest is almost 50% of all the feature, if not more, were about serialization. How do we transform the input JSON inside our CQRS object? And in the other way, how do we output it? So it's mostly about some custom value objects or some custom classes that we have, like the decimal number, which is a float abstraction. We have some CQRS commands that need to be injected inside a constructor instead of the getter setters. We can convert the scalar for our value objects. Multiple things, multiple arguments. We have certain use cases when we have setter methods in the CQRS command, which need multiple parameters and not regular setters. And other stuff like getters that do not start with get is or stuff like that. So how do we implement all this? We really like the approach of API platform because everything is in one class. And for our contributors, it's easier to contribute. You don't need to mix everything in multiple config files. So it's just one class to rule them all. You can use PHP attributes, which keep everything centered inside the class field. We also took the opportunity to create this new class to improve the naming of our entities, and because the CQRS naming was sometimes kind of mixed up. And to do this, we use a lot of custom configuration for the provider and processor. Most of them are passed through the extra properties, which is an array in which you can pass mostly what you want. And all this is done without touching the existing API configuration so that it is still usable, and we make sure that all our code is correctly separated. So what does it look like? Roughly, here you can see that you have a basic API resource with a GET. We define the provider, and as you can see, we have those extra properties, but I will get more in detail with that. So the GET and the delete resource, you can see that we use the query provider that I explained earlier. We explained to it that we need to use this CQRS query, which is get API client, and a command processor with the associated CQRS command, also delete API client command. For the delete, we have an extra parameter, output false, because we don't want any return. We had many other things that we needed to customize for the delete, but I will explain to you it a bit later as well. And for the post and update, it's basically the same principle. You can define a command handled by the processor. And you can see here that in the example for the patch, we have a command and a query, which means that after we execute the edit API client, we will get the full API client so that the REST API return everything. So that's the basic of what we needed. It's our basic POC. But we didn't want to stop there. We wanted to make the DX easier. So all those extra properties that are a bit ugly, we did not put them to be used this way. So instead, we created some custom metadata operation that actually extend the HTTP operation. So they are all prefixed with CQRS so that the contributor clearly understand that they are using our custom CQRS implementation. And we emphasize on the action of what it does, like the CQRS create actually does a post behind, the update does a patch, and this way the contributors who are not at ease with the REST API convention don't need to worry about it, and it's more explicit with this naming. And you can see the same principle for CQRS get and CQRS delete. Now about the module integration. We started with the mind that all modules need to be able to extend this API resource. And even our core APIs won't be in the core itself. They are already placed in a native module, which is PS API resources. This way, we can ensure that everything is already modular, because even us have to do it this way. We can also release this module independently from the core, which is a good thing for us, because we knew we wouldn't have time to implement all the endpoints when the 9.0 was released. So in this way, we can release the module afterwards and enrich the endpoints independently from the core release. And it is based on a very simple convention. You just need to respect this module folder structure, so SRC API platform resources. So here you can see an example. And as long as your files are in this folder, we automatically loop through all the modules that have this folder, and it's automatically appended to the configuration. So a bit about the custom mapping, which was something that we struggled a little bit with. And as Antoine said earlier, he developed a new component for this, so we probably won the first one. But we need to adapt the naming of our CQRS command because, let's be honest, they were sometimes a bit badly developed. The ID don't match between the command and the result. We have multi-language field that always start with get localized. We don't want that anymore. We want to be stricter, as I said, with our naming convention so that the naming in the API will be cleaner. And so to do that, we need a way to adapt all the field names between the API resource and the CQRS object. And to do that, we introduce yet another extra properties, which is also a property inside our custom operation. So it's a basic mapping. It's based on the property path component, and it allows you to rename the data in the flattened array that are used during the normalization process. Nothing fancy, but it does the job. Regarding scopes, as I said, we wanted also everything to be extra simple regarding the security and how you configure your endpoints. So we added another extra property, which is scopes. You can also use it with our custom operation as a variable. They are defined directly on the endpoint as a simple list. It's just an array of the scope that you need to use this endpoint. And behind the scene, we transform it automatically into roles and into security rules so that you don't need to worry about it, but it's easier for configuration. It's also easier for us to extract the list of the scopes that will then be used in the OpenAPI documentation and inside the back office. So the second view that you can see here, when you create some API client, when PrestaShop is used as the authorization server, you get automatically the list of all the scope that were defined on the endpoints. And the same thing works for the OpenAPI documentation. So in Redoc or Swagger, well, not Swagger because it doesn't really display them, but it helps our user to know which permission they will have to use for each endpoint. So about the delete operation, which was the one we struggled more, and it was fixed only a few weeks/months ago, I think. We had a clear view of what we wanted with how our delete API works. So we wanted no return, because once the entity is removed, we have nothing to display. We just want to have a 204 HTTP code as empty body to be sure that everything went well. So it's okay if you use output false. We also needed nobody in the request, and that was trickier because it's not really possible by default in API platform, and it created some errors because the JSON encoder doesn't accept an empty body, so we had to always send a small JSON object, which didn't make sense for us. So we added yet another allow empty body extra property, and it's automatically interpreted in a decorator early in the process, so that when we have this extra property with an empty body, it doesn't trigger any error. There were also other stuff that were handled by the platform, like avoid that the read provider is triggered, but we do need the deserialization process to be executed because that's the part that executes the processor. So all those custom or different, how do you say, properties were kind of hard. We could have documented in our dev doc that we expect all our contributors to use every time those settings, but it will be complicated. And the good thing is that we have those custom operations, so we can handle all the default parameters inside the class. And just in case we are curious how it works internally, it's actually, so you don't see it, but you have a constructor with a bunch of parameters that are the same as the regular operation, and we just do in the constructor, we get all the defined vars that may have been defined, we override the one that we need, and we don't modify any of the others. And all our custom operation works the same way. One of the last feature that we needed, we have some localized value in PrestaShop, which means a product can be expressed in multiple language. The problem that is our DB structure uses some language IDs, which are integers, and so do our CQRS objects. And it's not really convenient when you send your JSON to have to index all this data by a language ID. So we introduced a custom PHP attribute. So you only have to set this PHP attribute on the field that is localized, which is obviously an array. And internally, the JSON input will be automatically converted. So the object indexed by locals will be transformed in an object or an array indexed by IDs and vice versa. And in the end, it allows us to have a much easier format to use, both for input and outputs. And finally, all the customization that I explained here, they work well for our use case, but then they were not in tune with the OpenAPI doc because this was some common, some custom behavior. So we needed to adapt it. For example, when we create a product, we only have like 3 parameters, but since it was defined on the same class with multiple fields, and I now know that maybe it's not a bad practice and we should split our API resources. But anyway, for now we needed this, so we defined this as the input class, so that OpenAPI automatically understands that it needs to only display the 3 parameters that we need and not the whole JSON schema. We also implemented a decorator to handle all the customization that we have, so that the localized value automatically gets some example adapted with the local. The decimal number won't be displayed as object, but as float, because we expect float for this decimal number abstraction. And it handles the multi-parameter setters that I explained earlier and display it in a sub-object. And the custom mapping also needs to be applied, because if we don't, it will use the mapping from the CQRS object, which is not good. We always want the API resource naming to be the base of it all. And finally, it will group all the API resources that we have by domain, because we can have multiple classes, but we want them to be regrouped inside, for example, the product domain. So we use the namespace to guess the domain it's assigned to and override the default tag, so that this way all the endpoints related to product, even if they are defined on different API resources, they are still under the product domain. And here you can see an example for the body. We can see that the localized value have good example with localized value by local, and that the redirect action, which is multiple parameter setter, is displayed as a sub-object. So the conclusion about this all. So we sometimes struggle with the framework, but I think it's mostly when we needed to do something that was out of the box. So it kind of makes sense. But the documentation is really good, and I know that it's really hard to maintain documentation because we also have an open source project. Just as when you do not send the path, you need to find that by yourself sometime where you will need to modify something, which was kind of hard to figure out, but not impossible. And mostly because there is already a clear definition of what the provider and the processor need to do. So you can understand very easily early in the process how you can customize the API platform. The automatic open API doc was critical for our need, and it works really well. The components have a clear separation of responsibility. So even when you don't know, and because you can't find in the documentation what it does, you can guess it by going through the code. And the rapid development, as I said, will definitely be a plus for our community. But to handle all this, I would recommend using Xdebug. It helps us a lot to understand how the workflow behaves, how the framework is organized, and you can see clearly all the decoration chain, which in the end allows you to find what you need to override for your needs. And I will stop here, and I would like to thank you, all the people that were present for this presentation. That was a bit of a struggle for me, as you can see. And thank you for API Platform for inviting us.